Okay, well, thank you very much for joining this morning. We'll make a start. And welcome to this session on new EU rules on maximum levels for mineral oil aromatic hydrocarbons. My name is Chris Downs. I'm part of the co-lead AGRINFO team, and I will be sort of moderating this session. Thank you, Bela. Then the next slide. Um, can you see the next slide?
Oh,
Yeah,
okay.
super.
Yeah.
Thank you very much. Yeah. So there is interpretation this morning into French. Actually, there's a message there in Spanish, which may not be particularly helpful if you are French speaking. But basically, if you click onto the world at the bottom of your screen, interpretation, then you have the option of listening in French. If you don't see the world, then there are three little dots at the bottom of your screen. And if you click on those dots, then you will see the world and you will be able to listen to the French version. There is also the option of cutting out the original English. That will mean that you'll be able to hear the translation better. Okay, thank you. Next slide, please. So we're very pleased this morning to be joined by Wille van Hersden, who works in DG Sante at the European Commission. And Wille will be taking us through the content of the upcoming regulation and also the recommendations in relation to MOAH and MOAH monitoring. And then the second part of this session, we have Klaus Michael Rieber, who is an expert in food quality with a long experience working in the food industry and particularly on this mineral oils issue. And Michael will be talking to us about the potential risks to trade, about the sources of contamination, and setting out some of the strategies that you may want to take as exporters in order to tackle and prepare for the new regulation. I see in the chat that it's a question of echo certain people. This may be due to the app, the Zoom app that you are using. It is not something that we can control. So the best thing then is potentially to leave and then come back if you have that problem. So after each part, we'll have a questions and answers session. If I could encourage you to write your questions, because we're so many people this morning, it's not possible to open the microphone. But if you could put your questions in the Q&A rather than the chat, it would make it just a little bit easier for us. If you could put your questions in the Q&A box. And if you can't see the Q&A again, if you click on the three dots, then you will see the Q&A. And so this will give us it's give you an opportunity for clarifications and to ask your questions. Next slide, please, Vera. So just very briefly, let me explain who we are. So Co-Lead is an international non-profit organization, and we have been working on development projects in this field, in the field of sustainable agriculture, for the last 20 years. And this is an EU-funded project, and it is a project, it's an information system, and the aim is really to provide up-to-date information on all recent and upcoming changes to EU rules. Thank you, Vera. So why did the Commission think that such a program would be a good idea? So it is recognized that it is very difficult for exporting countries and often particularly in low middle income countries to keep track of all the changes to EU rules. And so what AgriInfo tries to do firstly is to monitor all rules that we think will have a potential impact on exports from these countries. We try to bring all that information together into one place. I mean, there are lots of information sources, but it's sometimes difficult to know where to look for information. And then finally, what we try and do is to make things a little bit simpler and clearer. EU legislation is very complicated. And so what we try and do is to make those rules really as simple as possible. The rule changes, explain them as simply as possible. So basically getting information to the people who need it, when they need it, in a form that is understandable. Thank you for that. And so we have all this information on our website. If you haven't yet had the opportunity to visit the website, this is the address, and I would encourage you to do so after this session. But I won't delay any longer. Let us get to the issue in hand, and I'll hand over to Vela, who will be presenting the regulation itself. Thank you very much, Vela.
Thank you. So I will explain to you the upcoming legislation on mineral oil hydrocarbons in food, and I will start with this first slide on what exactly are mineral oil hydrocarbons. Well, these are substances that are mainly derived from crude oil, but they can also be produced synthetically from coal, natural gas, and biomass. The group of mineral oil hydrocarbons contains many thousands of different substances. And within this group, there are two main subcategories. The first subcategory are the mineral oil aromatic hydrocarbons, which are abbreviated as MOAH. The second group are the mineral oil saturated hydrocarbons that are abbreviated as MOAH. Now, as regards these mineral oil aromatic hydrocarbons, or MOAH, the European Food Safety Authority concluded that this substance group contains mutagens, carcinogens, and of particular risk, even genotoxic carcinogens. EFSA assessed the exposure of EU consumers to MOAH and concluded that the current exposure is too high, so that this can cause health risks for consumers. So for this reason, in the EU, maximum levels will be set for MOAH in many foods, and there will also be some further monitoring recommendations. Then the mineral oil saturated hydrocarbons, or the MOAH. These are substances that are known to accumulate in various organs, such as the liver and the fat tissue of humans. And EFSA concluded that the current exposure to MOAH does not raise health concerns, but that the margin for a safe exposure is very limited. In practice, this means that if the exposure to MOAH would increase a little bit more, then it would be of health concern. Now, as you know, that when you know that in the EU already since 2017, measures are being taken to limit the presence of MOAH in food, then it's not difficult to understand that if some of these measures would be dropped, the exposure would increase again and there would be health risks. So taking all this into account, it has been decided for the time being not to establish maximum levels for MOAH in food, but to carry out further monitoring and measures for reducing the presence of MOAH in food. How do these mineral oil hydrocarbons end up in food? Well, one of the pathways is environmental contamination. So they can end up into food via contact with exhaust fumes from power plants, from motor engines, from heating burners. They also can end up into food via agricultural contamination. For example, the leakage of motor oil or lubricants from farm machinery, such as harvesting equipment, and also via the use of pesticides that contain paraffins that are contaminated with, for example, MOAH. Furthermore, an important source of contamination is the migration from packaging to the food. And there in particular, mineral oil treated jute bags are a source of contamination, a problem that can be avoided by using vegetable oil treated jute bags. Also, printing inks can contain mineral oil hydrocarbons, and so when recycled paper or cardboard is used in contact with food, also from there, the mineral oils can migrate into the food. Also, paper or cardboard that is treated with waxes that are contaminated can be a source of contamination. And then furthermore, the mineral oil hydrocarbons can end up in foods at all the different steps of the food processing chain. For example, via the leakage of lubricants from food processing equipment. Also from the use of contaminated additives or technical aids, for example, mineral oil containing non-stick agents, release agents, mineral oil containing anti-dust agents. They also might end up in food via extraction processes through the use of contaminated extraction solvents, for example, contaminated hexane, or via the use of contaminated paraffins for the recuperation of those extraction solvents. And also here, drying processes are a source of contamination, and not only the contact with burning fumes, but also, for example, drying foods on asphalt might be a source of contamination. As you see, all these sources of contamination are avoidable when using good practices at the different steps of the food production chain. And for this reason, the maximum levels for MOAH, so the aromatic hydrocarbons, will apply regardless of the source of the contamination. Now, what are the rules today? Well, so far, no maximum levels for MOAH in food are applicable yet in the EU. However, in the EU, we have general legislation that states that all the foods that are placed on the EU market must be safe. So this is explained in the EU's General Food Law Regulation 178 of 2002. And once EFSA had concluded its evaluation on MOAH in food in 2022, the member states in the EU agreed that awaiting the establishment of former maximum levels for MOAH in food, that already enforcement against MOAH in food needed to be done on the basis of this EU's general food law. And so the EU member states agreed on harmonized thresholds for the enforcement of MOAH in food. They agreed to withdraw and, if necessary, recall products from the market when the concentrations of MOAH in the food would exceed the limit of quantification. This limit of quantification is 0.5 milligrams per kilogram for foods with a fat content of 4% or lower, 1 milligram per kilogram for foods with an intermediate fat content, and 2 milligrams per kilogram for foods with a fat or oil content of more than 50%. Now, on this slide, you can see the number of notifications on mineral oil hydrocarbons that were made in the EU's rapid alert system for food and feed. And so the statement of the EU member states on the enforcement of MOAH in all foods was made in 2022. And so you can see clearly that after that statement by the EU member states, there was an increased number of food safety alerts related to the presence of mineral oil hydrocarbons in food. On this slide, you can see in for which foods the most safety alerts were made in the period between 2019 and 2026. You see that the main category are edible fats and oils. This has to do, amongst others, with the packaging of the oil seeds and the oil fruits in jute bags, drying of certain raw agricultural commodities on asphalt, and also with leakages of lubricants from the mills for producing the oils, and also the extraction processes are an important source of contamination. Then we see also a lot of contaminations in rice. Here again, the jute bags are a source of contamination, as well as the use of anti-dusting agents and use of, for example, wax paraffins to make the rice shiny. And then a third category with a lot of contaminations, we have the class of the dried herbs and spices. So here also drying processes play a role, as well as packaging. On this slide, you can see which countries have reported the highest amount of food safety alerts related to mineral oil hydrocarbons. So these were mainly the Netherlands, Belgium, Germany, and Switzerland. However, it is expected once the maximum levels will become applicable that we will see also more controls and findings in other EU member states. Then we come now to the part of the presentation that deals with the maximum levels for the mineral oil aromatic hydrocarbons in food. So as a basic principle, in the EU, maximum levels are set on the basis of occurrence data, following the as low as reasonably achievable principle when following good practices at all the steps of the supply chain. Now, we know that when you apply good practices, the presence of MOAH in food can be avoided. So this means that for this particular contaminant MOAH, as low as reasonably achievable means below the limit of quantification. So therefore, we started from the default principle, from the basic principle that the mLs at the limit of quantification should be achievable for MOAH in food. However, when looking at the occurrence data, we also saw that for certain specific food categories, currently a large part of the production cannot comply yet with a maximum level at the LOQ. And we also saw that there were certain foods that contain substances that are produced by plants, the plants themselves, that for those foods, the limit of quantification is higher than 2 milligrams per kilogram, because these substances produced by the plants can interfere with the analytical method. So taking all this into account, maximum levels were proposed at the limit of quantification for quite a wide range of foods, which are the oil seeds and oil fruits. certain categories of fats and oils, such as, for example, sunflower oil, for tree nuts and pulses, for cereal grains and products derived from cereals, for milk and dairy products, for cocoa mass and cocoa powder, and for foods for infants and young children. And these MLs at the LOQ will apply from 1 January 2027. Then for certain foods for which we saw that a large part of the production cannot yet comply with the maximum level at the LOQ, or substances in which there are foods in which there are interferences, MLs higher than the LOQ will apply from 1 January 2027 with a clear timeline for reducing them to the LOQ by 1 January 2030. And these are certain vegetable fats and oils, spices, dried herbs, dry tea and herbal infusions, but only if they are used as an ingredient in food, and dry instant tea and herbal infusions, and also food supplements fall in this category. And then there is a set of MLs that will only apply at a later date. So the ML for cocoa beans will only apply from 1 January 2030. Also the MLs for oils and fats destined for further refining and labeled as such will only apply on 1 January 2030. The maximum level for olive pomace oil and refined olive pomace oil will apply from 1 March 2028, and the maximum level for the other olive oils from 1 March 2027. Now I have some slides in which I will walk you through the different maximum levels that will become applicable. So on this slide, you see the maximum levels for milk and dairy products. These are maximum levels at the limit of quantification. And so for dairy products other than milk or butter, the maximum level will depend on the fat content of the food. So then the maximum level will be or 0.50, 1.0, or 2.0 milligrams per kilogram. Particular point of attention for this category 5521. So dairy, butter, and fats. Here, this is explicitly mentioned dairy in order to make the difference with cocoa butter, which falls in the category other oils and fats in the regulation, for which in the initial ML of 4 milligrams per kilogram will apply, which will then be lowered to 2 milligrams per kilogram. Then the category of the cereals. So for cereal grains, a maximum level of 0.50 milligrams per kilogram will apply from 1 January 2027. Then for products that contain more than 80% cereals, a maximum level will apply depending on the fat or oil content of the product. So 0.50 milligrams per kilogram for products with a low fat content, and 1.0 milligrams per kilogram for products with a fat content between 4 and 50%. This maximum level of 0.50 milligrams per kilogram for cereal grains will not apply to cereals that are used for beer production, provided that the remaining cereal residue is not sold as food. This is because when you brew beer, the MOAH remains in the cereal residue and does not go into the beer. So therefore, we considered it not necessary to have a maximum level for cereal grains used for beer production. However, if then that remaining cereal residue that contains a MOAH is used for further processing to food, for example, for preparing a certain meat replacement product. Then, of course, the MOAH is ingested. So for this reason, if the residue is sold as food, then the ml for the cereal grain will apply, and the ml for then the final processed food will need to be calculated, taking into account the appropriate processing factor. Later on in the presentation, I will explain a bit more on these processing factors. Then on this slide, you can see the maximum levels for several categories of foods for infants and young children. And so for all these foods, the maximum level at the LOQ will apply, and this maximum level again depends on the fat content of the product. Then which maximum levels will apply to food additives? Well, in case the food additives are produced from a food source, that food has to comply with the maximum level that is established for MOAH. And then the ml for the food additive can be calculated taking into account a processing factor. If a food additive is prepared from oils and fats, then the oil or fat has to comply with the maximum level that is established for the oil as sold to the final consumer or used as an ingredient in food. However, before 2030, it will still be allowed to use oils destined for further refining for producing food additives. So these oils destined for further refining, before 2030, there will be no ML applicable to them. You can still use them for preparing food additives. However, then you have to first refine them so that they comply with the maximum level for the oil sold to the final consumer. And then from that compliant oil, further food additive production can be done. For food additives for which that are not produced from a food source or that are produced from a food source for which no maximum level is set, to those no maximum level will apply. However, I can tell you that under the EU's food additives legislation, currently also the discussions are ongoing for establishing a maximum level for MOAH in certain waxes like microcrystalline wax. And also discussions are ongoing for maximum levels for lecithins. Then on this slide, you see the mLs for a few other food categories, all mLs at LOQ. So mL for oil seeds and oil fruits, tree nuts, pulses, cacao mass, and cacao powder. Then we come to the mLs applicable to the category vegetable fats and oils. So we saw that certain oils can already now comply with a maximum level at the LOQ, but that for certain specific types of oils, currently a large part of the production cannot yet comply with such a maximum level. Therefore, for certain oils, mLs are set at a level above the LOQ in January 2027, and these mLs will be gradually reduced over time to an mL at the LOQ that will apply from 1 January 2030. So this gives producers of these oils some more time to implement the necessary mitigation measures to ensure compliance with mLs at LOQ by 2030. So these maximum levels at from 1 January 2027, they will apply to oils sold to the final consumer or used as an ingredient in food. The oils, the mLs for oils that are destined for further refining and that are labeled as such, they will only apply from 1 January 2030 onwards. Now, we know that the presence of MOAH in food can be reduced to a certain extent via refining processes. So why are we then still keen to apply maximum levels to the crude oils from 2020-30 onwards? Well, this is because when you refine an oil that is contaminated with MOAH, then the least toxic light MOAH fractions get removed from the oil, and the heavier long chain branched MOAH fractions with multiple rings, they stay in the oil. So this means that if you then have a refined oil that contains a MOAH concentration of, for example, 2 milligrams per kilogram, this oil contains a concentration of the most toxic MOAH. And so this oil will be more toxic than a non-refined oil that contains 2 milligrams per kilogram of MOAH, which contains for the bulk the less toxic MOAH fractions and only a limited fraction of the most toxic MOAH fractions. So therefore, in the EU, we believe that the only way to protect consumers against the health risks from MOAH in food is to avoid the contamination from the source of the production chain rather than to try to remove it afterwards via refining. So for this reason, from 1 January 2030 onwards, the ml for MOAH of 2 milligrams per kilogram will also apply to oils that are destined for further refining. We believe that by doing so, with having this deferred application date of 1 January 2030 for the crude oils, we are giving the industry the necessary time to adapt. So, but it is important that those food business operators now take the necessary action to be ready in 2030 to ensure compliance with an ml of 2 milligrams per kilogram for the crude oils. On this slide, you can see a table with the maximum levels for the different categories of oils. So for maize oil, rapeseed, sunflower, soybean, and linseed oil on 1 January 2027, immediately an ml at the LOQ of 2.0 milligrams per kilogram will apply. Then you see there are other categories where we start with a higher maximum level that then is further reduced in 2028 or 2029, and then ends up in a maximum level at the LOQ by 2030. As you will see, for oils that are prepared from fish and other marine organisms or oils prepared from algae, the maximum level is not reduced to 2 milligrams per kilogram by 2030, but to 5 milligrams per kilogram. This is because these oils contain interfering substances that are produced by the marine organisms themselves and that interfere with the analysis. So we consider that the maximum, the LOQ for these oils is 5 milligrams per kilogram. So therefore the ml is only reduced to the LOQ of 5 milligrams per kilogram. Then for the category olive pomace oil and refined olive pomace oil, there the ml of 10 milligrams per kilogram will only apply from 1 March 2028. and it will be reduced to 5 milligrams per kilogram by 1 March 2029 to end up then in a maximum level of 2.0 milligrams per kilogram by 1 January 2030. So please pay attention that certain of the mLs for the olive oils become applicable or change in March and not in January. So these mLs for olive pomace oil and refined olive pomace oil, they do not apply to lampante and to crude olive pomace oils because these are subject to further treatments. No mL will apply to lampante and to crude olive pomace oil. And then there is category 5527, the category of other fats and oils. So these are the fats and all the fats, edible fats and oils that are not listed in the rows above. And to these, a maximum level of 4 milligrams per kilogram will apply from 2027 onwards, which will be reduced to 2.0 milligrams per kilogram by 2028. This category contains, for example, palm oil and also cocoa butter. From this category of other fats and oils, also here lampante and crude olive pomace oil are exempted, as well as essential oils. So to lampante, crude olive pomace oils and essential oils, no maximum level will apply. Then which mLs will be applicable for spices, tea, and herbal infusions and dried herbs? The ml will be 10 milligrams per kilogram from 1 January 2027 and will be reduced to 5.0 milligrams per kilogram by 1 January 2030. So here also the ml does not get reduced to 2 milligrams per kilogram, but only to 5 milligrams per kilogram because of interfering substances that are produced by the plants, which make the analysis more complex and so make that the limit of quantification is higher. The maximum level for dry tea and dry herbal infusions will not apply when they are used to prepare an aqueous brew, because the MOAH remains in the tea or the herbal infusion and does not go into the brew. However, when the dry tea or herbal infusion is used as an ingredient in food, then consumers consume also the MOAH. So in this case, then the maximum level will apply. And the same goes for instant tea and herbal infusions. So these are entirely solubilized in the drink. So you ingest the tea with the MOAH. So also to the instant ones, the maximum level will apply. For food supplements, the same maximum levels will apply. Also 10 milligrams per kilogram from 1 January 2027 and 5 from 1 January 2030. Here again, also the 5 milligrams per kilogram refers to the LOQ, which is higher in some food supplements because of interferences. Then now a few slides to just repeat which maximum levels will only apply from a later date. So these are is the maximum levels for the crude oils, so the oils destined for further refining. So there the maximum level of 2 milligrams per kilogram will apply from 1 January 2030 for most oils. For oils from fish and other marine organisms and algae, the maximum level of 5 milligrams per kilogram will apply to the crude oils from 1 January 2030. Then, as we also mentioned, for certain olive oils, certain maximum levels will only apply from 1 March onwards. So 1 March 2028 for olive pomace oil and refined olive pomace oil, 1 March 2027 for the other olive oils. No MLs will apply to crude olive pomace oil and lampante, also not from 2030 onwards. Then for cocoa beans, the maximum level of 2.0 milligrams per kilogram will apply from 1 January 2030. This is to give third countries more time to implement mitigation measures, such as replacing the mineral oil treated jute bags by vegetable oil treated jute bags that are MOAH free. Because if you treat jute bags with a vegetable oil that is contaminated with MOAH, there might still be a contamination. However, the fact that the ML for cocoa beans will only apply from a later date does not mean that we will not have MLs applicable in the EU for chocolate and confectionery products, because the maximum levels for cocoa mass and cocoa powder already apply from 1 January 2027. And so the maximum levels for chocolate and confectionery can then be calculated from the maximum levels for cocoa mass and cocoa powder, taking into account a processing factor. So for chocolate and confectionery, we will also already have applicable maximum levels from 1 January 2027. We also will establish specific maximum levels for certain categories of processed and compound foods. From 1 January 2028, a maximum level of 2.0 milligrams per kilogram will apply to products that contain more than 50% of fat oil content and that only contain fats or oils from the two lowest maximum level categories. So these are basically categories 5, 5 to 1, with, for example, sunflower oil. Category 5, 5 to 6, this is the category of the other olive oils. And category 5, 5 to 7 with all other remaining oils. So this category contains, for example, palm oil. And so in these cases, when from 1 January 2028 onwards, a food contains more than 50% of an oil to which at that date an ml of 2 milligrams per kilogram will be applicable, then there will be no need anymore to calculate the maximum level taking into account a processing factor. It will just be the level of 2.0 milligrams per kilogram that will apply. And then from 1 January 2030 onwards, we will have fixed maximum levels for all processed and compound foods, provided that they contain an ingredient for which a maximum level is set. Then if the final compound of processed food contains less than 4% fat or oil, the maximum level will be 0.50 milligrams per kilogram. When the food contains between 4 and 50% fat oil content, the maximum level will be 1.0 milligrams per kilogram. And for the foods containing more than 50% fat or oil, the maximum level will be 2.0 milligrams per kilogram. These fat contents refer to the labeled fat or oil content. In first instance, so competent authorities when controlling foods will first instance look at the labeled fat content. However, if the food is not labeled as regards the fat content, or when the authorities think that there is an error in the fat content, then the authorities can also determine the fat content themselves for deciding which maximum level applies. Now, the fact that maximum level for processed and compound foods will only apply from 1 January 2030 does not mean that in the period before, no maximum level will be applicable to processed and compound foods. No, this is not the case because the maximum levels are included in the annex to Regulation 2023/915. And Article 3 of that regulation indicates that when no specific maximum level is set for a processed or compound food, then the maximum level has to be calculated, taking into account the maximum levels of the ingredients, the ingredient composition, also the necessary dilution or concentration factors, and also the limit of quantification. Because if you calculate a maximum level that is below the limit of quantification, okay, this is of course not feasible to control then, so then the maximum level is increased to the limit of quantification. So these are provisions that you do not find back in the regulation on maximum levels for MOAH in food, but these provisions are included in the basic contaminants regulation, to which the maximum levels for MOAH will be added. So Article 3 of Regulation 2023/915. So here on this slide, you will see an example of how to determine the maximum level for a compound food. So suppose we have a jar of grilled paprikas in sunflower oil. So to the sunflower oil, a maximum level of 2.0 milligrams per kilogram applies. If the product contains 20% sunflower oil, then this will contribute to the maximum level 0.40 milligrams per kilogram. Then for paprikas, no maximum level is set. The contribution of the paprikas to the maximum level will be 0. So then we end up with a maximum level of 0.40 milligrams per kilogram for a product with a 20% fat content, while the limit of quantification for such a food is 1.0 milligrams per kilogram. So in such case, then this Article 3, the amendment that is foreseen for this article, will mean that you can increase then the maximum level to the LOQ of 1.0 milligrams per kilogram. So this is then the maximum level that will apply to the grilled paprikas in sunflower oil. More explanations on calculating processing factors and on the enforcement are included in an FAQ document that is available on the Commission's website, and a link to this FAQ is included in this slide. Then we now move to the recommendations for the monitoring of MOAH and MOAH in food. So, so far, no maximum levels for MOAH are established for all foods. So certain categories, there is no maximum level. And a reason for this is that for certain categories, we had insufficient data available to allow to establish a maximum level. So therefore, we consider it important that further monitoring for MOAH is carried out, in particular in these foods in which we know that MOAH can occur, but we could not set a maximum level yet. Then for MOAH, while today the exposure to MOAH does not raise health concerns, we know that if it would increase a bit the exposure, that then there might be health risks. So for this reason, it is considered important to continue the monitoring of MOAH in food, and also to continue to take measures to avoid the presence of MOAH in food. So this recommendation recommends to collect further data on MOAH and MOAH through monitoring. And this requires a collaboration between the competent authorities and the food business operators in the period between 2026 and 2029. It is of particular importance that this monitoring also includes and mainly focuses actually on processed and compound foods, because in processed and compound foods, typically higher levels of contaminations are seen, because at the many different steps of the production chain of a processed food, additional contaminations can be introduced. So in order to give some guidance to food business operators on when it's necessary to carry out investigations towards the sources of the contamination, indicative levels are recommended. These indicative levels are recommended for MOAH, but only in foods for which no maximum level is set, and for MOAH. And so the indicative levels are thresholds. Once the concentrations are above this threshold, then it is recommended that investigations are carried out towards the source of the contamination. And then once the source is found, that of course measures are then taken to avoid the further contamination in the food. However, the indicative levels are no thresholds for placing food on the market. So food will not be removed on the market only because the indicative level is exceeded. However, member states in the EU still retain the right not to allow products on the market in case of very high levels of MOAH and MOAH in foods for which an indicative level is set, on the basis of a national risk assessment following Article 14 of the General Food Law. So in principle, the indicative levels themselves are not used as thresholds for removing products from the market, but member states still remain free if they consider that high concentrations of MOAH or MOAH can cause health risks, to still take enforcement action. Then here a list of foods for which the monitoring of MOAH is recommended together with the indicative levels. So an indicative level is recommended, for example, for coffee beans or for cereals used for beer production. An indicative level of 2 milligrams per kilogram is recommended for processed fruits, vegetables, meat, offal, fish, seafood, and eggs. Also for the crude oils destined for further refining. An indicative level of 5 milligrams per kilogram is recommended for tea and herbal infusions that are intended to make an aqueous brew, and a level of 10 milligrams per kilogram for essential oils. Then on this slide and the following slides, the foods are listed for which the monitoring of MOAH is recommended, together with their indicative levels. So for different types of oils, indicative levels are recommended between 15 and 50 milligrams per kilogram. Furthermore, an indicative level of 15 milligrams per kilogram is recommended for cocoa butter, spices and dried herbs, tea and herbal infusions, and food supplements. And then on this slide, you see the foods for which the 3 lowest indicative levels are recommended. So an indicative level of 1 for liquid, infant and follow-on formula. An indicative level of 5 for example, tree nuts, cereal grains, coffee beans, processed fruits and vegetables, and an indicative level of 10 for cocoa beans, cocoa and chocolate products and confectionery, processed meat offal, processed fish, seafood, and processed eggs. Now, in case that you have a processed or a compound food that contains only ingredients for which an indicative level is set, and no specific indicative level is set for that processed food, in that case, then the indicative level can be calculated taking into account the appropriate processing factor. So this means that indicative levels can be calculated for MOAH in processed and compound foods only if they contain only ingredients for which no MOAH ML is set. Because from the moment that a compound or processed food contains one ingredient for which a maximum level for MOAH is established, then in that case, a maximum level will apply to the entire food, and so it is not needed to calculate an indicative level. And then, of course, for MOAH in food, no maximum levels are set. So in case that no specific indicative level is set for the processed or the compound food, then the indicative level for MOAH can be calculated taking into account the appropriate processing factor. Now, what are the timelines? Well, probably many of you are aware that in March of this year, the draft regulation on maximum levels for MOAH in food was notified to WTO. And many WTO country members submitted comments on this draft regulation. We carefully looked at all these comments, we considered them and took into account some of them for a revised version of the proposal, which received a favorable vote by the EU member states on 13 May of this year. Now, this proposal now will undergo procedures of scrutiny by the European Parliament and the Council. And its adoption is expected in October of this year, so that then the maximum levels will become applicable for most of the foods on 1 January 2027. So happy to hear whether you have specific questions on this presentation.
We are hoping to do a written question and answer document in the coming weeks that will bring together all the questions. So we'll be sending that round to people once we've had a time to compile all the questions from the 2 sessions we've had, and that will be sent to you. So we may not have the opportunity to answer all the questions, but we will endeavour to do so in the written document. So Michael, over to you for the second presentation. Thank you.
Yeah, hello to everybody. Thank you for having the opportunity to speak today. And I just want to now, after Verle has told us about the legislation in a very detailed way, you will ask, how all this stuff, MOAH, will come into the product, which path of migration are there, and what can we do in order to mitigate and to lower these paths, or to avoid that mineral oil, MOAH and MOAH, is migrating into our food. So this is the story and what I want to tell you in the second part. What can we do and how are we prepared for the MOAH maximum levels. This is the agenda. I will skip directly to the first point. So, who am I? May I introduce myself to you? I'm Michael Brieber, and I've been working for over 30 years in the food business, in the food industry worldwide, mainly in positions of quality director, quality lead. And since 1 year, I'm an independent consultant, freelancer, and I'm consulting food businesses and food operators in order to get or to have safe products. So food safety and quality is my main topic. What are really the implications within EU, MOSH and MOAH, or especially the MOAH maximum levels for the trading partners, like a lot of you are here in the auditorium? Principally, the operators must be ready by January 27 for most of the food to comply with the new maximum levels. There are some maximum levels that will only apply after 2027, so in 2028 and 2030, but 2027 is a crucial date. And this can have negative impacts on trade, of course. However, the EU and as Vale told, they have considered a lot of foods that have higher values than the level of quantification maximum levels. And so there would have been higher MLs considered for the first years after 2027. However, the mineral oil hydrocarbons must be mitigated at the source. This is also very important. EU and it's a good hygiene and manufacturing practice to not to have a spoiled food with a lot of contaminants and then to try to get those out afterwards in the processes, but to mitigate and to try to have clean products in the beginning. So we have to we should not remove much more later in the process, but to keep or to mitigate the traces at the source. This was also the discussion about crude oils for refining, if you remember. And of course, there are multiple paths of MOAH migration into food, and of course there are different solutions for each path, how they could be mitigated. Yes, what is the impact on trading partners, and are there also some advantages of the maximum levels in the legislation? Yes, there are. Mainly, we have clearer rules, specific maximum levels for specific products. We had the scope of paper, which was indicating these levels, threshold levels for food at the level of 2, 1, and 0.5 milligram per kilogram, according to the fat content. But now we have clearer rules for a lot of food categories and for a lot of food. And as I've already said, for certain foods, we have temporary higher enforcement limits for the first year. So for 27, 28, and the limits of quantification will then be achieved at 2030. So there is still some time for the food business operators to lower the migration of MOSH and MOAH into their products until 2030. Of course, there will be an increase, or we think that there will be an increase of controls of MOAH specifically across the EU, as there is the new legislation, and then food operators, but also the officials, when they will increase to test those foods. And it's a little bit the same than the first point I already mentioned. There is a more consistent approach to enforcement of foods containing MOAH above the maximum level. So this was, although there have been the scope of paper since 2022, there were some national differences how to approach to an enforcement in those cases. But now we have then from 2027 on, there is one contaminant law for MOSH and MOAH, for MOAH, and thus there is then a more consistent, or optimally a very consistent approach to enforcements like recalls and withdrawals. And of course, there will be increased demands by European companies and customers to the food operators outside of the EU, asking for evidence that the MOAH levels are, that they are under the maximum levels. So there will be more questions in the future. So what are the main entry roads or routes into food? And it's already since quite some years, with 2018, that the FDA, Food Drink Europe Association, has created this toolbox for preventing the transfer of MOSH and MOAH into food. And this paper is available here, also in the link. And I will tell you some more about this paper. So generally, there are three different paths from farm to fork into of MOSH and MOAH into food. First of all, it's indicated with the red color. It's coming from the very near surrounding of the food, which is mainly the packaging or the surface where it's stored, or these are some cases that are described there. And all the other possible ways from farm until the finished product, it's subsumized under contamination, which is here marked in blue. And the third path could be that there are even some ingredients, that there are some processing aids that are MOSH or contaminated with MOAH, and these are marked here in green. So there are typical three different categories of ways how MOSH and MOAH can enter into our food. So let's begin with the red color. So this is mainly the packagings, and in the meantime, we all probably know that using card box and paper, which is produced from printed paper or card box, there is a contamination via the printing inks when you recycle these used paper and card box. So the printing inks, they will contaminate the card boxes and papers when they are recycled. So what can you do? Basically, there are two different methods. So either you use fresh fiber products, so not from recycled card box. This will then ensure that there is no MOSH MOAH in your card box and paper. Or if you don't want to do this, or it's not possible to do this, then there is the other way to use a functional barrier between your card box or paper box packaging and your product. And what kind of barrier is optimal? Yes, you could of course use an aluminium foil, which is 100% tight, but there are also some products like EVOH or PVDC or PAs, or some plastics that are very good barriers, and others which are not mentioned in here, they are not. However, this is also kind of packaging. So if you transport your products in containers from the southern hemisphere of our world to the northern one, then there is, because of the climate impact and the change of temperature, then there is a formation of moisture and of condensation from the humidity of the air in the containers, and thus these containers are equipped with so-called linings or liners. So these are paper card box coatings inside the container in order to resorb the water. And you can imagine if these liners are produced from recycled card box, then there is a MOSH MOAH atmosphere within the whole container, which will then spoil our, let's say, will give a contamination of MOSH MOAH to the food which is inside there, if there is not a barrier around it. And like packagings, when we speak about packaging, also the jute bags are a possibly way of contamination of MOAH and MOAH, because these jute bags also want to be reused. And in order that these jute bags will, could be reduced for several times, they are treated with batching oils. Yeah, and if these batching oils are mineral oils, then it's clear there is a migration then from the batching oil to the content of the jute bag. But even if you use vegetable oil treated bags or jute bags, then there is still a possibility that they are contaminated. And it's an early bird. I will tell it later on. The Cacao Association, the European Cacao Association, and the European Coffee Federation, they have launched a project for these jute bags, which are which have specified limits of MOAH and MOAH and which are suitable for the food packaging. But also, if you, as Verle already said, if you store grains or seeds or fruits on asphalt or bitumen, then there is, of course, a migration of MOAH and MOAH into your product. So let's go to the blue color, which the FDA toolbox has mentioned or has described also. And there it's mainly the lubricants which are mentioned over there. So if you use for your lubrication or to lubricate your processes, your machines, your gearboxes, your belts, everything which is moving, if you use these NSF, so American US standard H1 oil, then you can make sure that the MOAH content is very limited, and then that there is no or nearly no migration of MOAH into your product. Although even if you use H1 lubricants, they are mainly the content is MOAH or products made of MOAH, made of mineral oils, which are analyzed as MOAH. So you cannot prevent MOAH in your products, even if you use H1 lubricants. And this is why, of course, you have to make sure that that these lubricants don't move from the chains, from the belts, from the turning parts, and migrate into your food too much. So you have to really limit the quantity of lubricants that are entering into your food anyhow, even if you use H1 lubricants. So these are typical other ways how MOAH can find its way from harvesting machines which are lubricated, or from the gearboxes of trucks. On the right side of the slide, you see some pictures, or it comes from chains, as you see it in the picture here with the palm bunches transport belt, or there are some gearboxes or motors above the belt which can drip on the product, or you see some here some shaking machines for harvesting olive trees or other fruit trees, and there are pneumatic oils in order to move these big parts. So these are all possible ways how MOAH and MOAH can migrate via the lubricants or mineral oils into your food. And this is why you have to prevent and to minimize the entry of lubricants as much as possible. And that's only the accidental, the accidental option that there is something happened is allowed. So if you are considering that there is a part of your lubricants entering in your food anyhow, you are on the wrong path. So have to minimize that. Not only by lubricants themselves, but also by compressed air, which compressors, they work also with mineral oils and lubricants in order to work. And there are so-called oil-free compressors, which limit then the content of MOAH and MOAH in the compressed air, which could then contaminate your product if you transport your product with compressed air, for example. But also, as Verli also already said, by combusting, by burning, there are gases that are formed, these combustion gases, or from drying. We see here some burning of the fields, or some drying option on coconuts here, direct drying. And these combustion gases, they mainly consist also of MOAH, and also a big part of them are MOAH. And so if you use these gases to dry your food, or your food is placed near a field where is the big fire, then you have a contamination of MOAH and also of a big part of MOAH in your product. Yeah, these are the other options. We see the concrete floor, which are spoiled with oil or with rubber or with some other contamination, which are mineral oil based. Or you see here the storing of palm bunches on asphalt or with bitumen. Or you see big tractors which have gearboxes, and there is a possible dripping of oil from the gearboxes and the machines of the tractors, of the harvesting and transport machines on the fruits. And you have the trimming of the trees. Here an example for olive oil. And if you do the trimming during the harvest and the olives are still on the trees, then you have a contamination of exhaust gases. Same with the harvesting. Here in this case, this is a harvesting machine for olive oils, for olive, and the combustion or the exhaust gases of those tractors and of those vehicles, they will then possibly contaminate the fruits. So these are other examples which from the blue color here, this toolbox. And last but not least, also already mentioned, you have a lot of, or at least some ingredients which have an E number, which are derived from mineral oils. We will see it on the next slide. And of course, there are also a lot of process aids, and which are mineral oils or produced from mineral oils. So, for example, a big like for the rice already mentioned, or for soy crush, the processors who transport this soy crush or rice, they want to avoid that there's a formation of too much of dust. So there is an anti-dust mineral oil based products. They are used in order to keep down the dusting. And this is heavily used for soy crush, but also for rice crush. There are some pesticide formulations, and I've discussed yesterday with a partner in Southern America, for example, for some fruits, and these pesticides formulation, they are mainly MOAH, they are paraffines, and these paraffines, they have the use that the pesticides enter more efficiently into the product, into the fruit, so into the tree, into the plant. So these are processing aid in the pesticide formulations. But there are also some release agents. We see here a nice picture of avocados, which are waxed, and via this wax, which is analyzed as pure MOAH. But even if it's pure MOAH, there can be also contamination of these waxes of MOAH, and then you have also higher MOAH values in your product. Here you see on this slide the E numbers of additives. So even beeswax, of course, it's not MOAH or it's not MOAH, but it's analyzed as MOAH. So if you make analytics from beeswax, you have a positive MOAH result. But also the other waxes and other E numbers you see here on this slide, they are derived from mineral oil, or they are analyzed as MOAH in the analytics. So if you have seen in your production or in the process, or you have discussed with your partners, with your suppliers, and you showed them these nice pictures, what can you really do in order to mitigate and to stop these migration paths? So first of all, look at your own process. Don't point your finger always on your suppliers, which some of us usually do. Look first at your own processes, and then if you find if you can exclude really that in your own factory you have a migration of MOAH and MOAH, then also or parallelly communicate to your suppliers worldwide and ask them to mitigate the risk in cooperation with you. And yeah, there are some suppliers and some partners which will say, "Oh, I'm not really interested in." And so start with those which are really willing to enhance the situation and are really willing still import or export into the EU. So first identify the risky suppliers, and some of the suppliers, they may have some risky products and non-risky products. So you have both to identify the risky products and from which suppliers are they coming from. And if you have identified that, then take a time and talk with them, possibly make an audit together with them, show these pictures, show the opportunities and the path that you have identified with examples and pictures. And then you go together with them, you go through the process, and you will for sure see some or even a lot of possibilities where MOAH and MOAH could enter into your or their product. And if you see them, then it must not be 100% the case that it happens really. So what you can do then, and I will come back to this later, you can do some step testings and analytics, of course, from your process in order to see where exactly in your process the MOAH or MOAH contamination takes place. So I want to show you 3 examples. So the first one is linseed or flaxseed here from Kazakhstan, and it's harvested and stored in this example in Kazakhstan. And then in Germany or in Europe, there is a pressing and filling of the oil. And what we have seen there, some of the pictures you already have seen, there are a lot of possible paths of contamination from diesel and lubrication, from the trucks, from the harvesters, but also from the drying. But in this case, you see a kind of indirect drying, which is a very good method. So indirect drying means that you have, of course, combustion gases from diesel or from mineral oil, which is burning. But these combustion gases, they are not used to dry the food, or in this case the seed, directly. But these combustion gases, they are used to heat up the second circle of clean air. And this second circle of clean air is then drying the food. And this is what's meant by indirect drying, in the opposite of direct drying. But we have seen also some leakages on the concrete floor, and there was also contact with asphalt floor. But what we identified in this case as the main impact and the main migration path was the extensive lubrication in the bearings in the cleaning process of the seed. Just to give you an example where it could come from. So the second example I would like to show you is the coconut production in the Philippines, can be also Malaysia or other countries. So the raw oil is pressed over there, and the refining could also be done there, but can be also done in Europe. And the steps in the Philippines or Malaysia are the harvesting, cracking the nuts, drying of the meat, and this is then called copra, the dried meat, and then the pressing and the refining and filling possibly are steps done in Europe. And here we've seen also some options where the MOAH and MOAH could enter. And here we see some pictures of direct drying. So when they got the meat of the coconut, the nice white meat of the coconut, there is combustion of wood, of charcoal, and of other burnable materials, and then the combustion gases directly dry the meat of the coconut. And if this is done in this way, there is a huge contamination of polyaromatic hydrocarbons and of MOAH and MOAH. And of course, you can do sun drying, and sun is not always shining, of course. There's also a lot of rain. So there is both usually. So there is drying, direct drying mainly, and of course sun drying. But we have seen also indirect drying. So as I told before, in a second circle, the first circle of combustion air, and then a second circle of clean air, and the clean air is drying then the coconut. Here you have also some possibly way of reused bags, which are dusty and which contain a lot of perhaps of charcoal from the drying process. I don't know what. And you have the expeller presses. Of course, in the press room where you press the coconut, there is no MOAH and MOAH. But of course, these presses have a gearbox and have a motor. And these gearbox and motors, they are of course separated from the press room. But in between the press room and the gearbox room and the motor room, there is a seal. And if this seal is defect, then of course there could be a lubrication migration from the gearbox room to the press room. However, in this case, we studied the migration path was really the exhaust fumes from the direct drying. And really, the indirect drying is key to avoid decontamination. I already showed you the picture in the Kazakhstan example with the linseed or flaxseed. So you have two different circuits how to dry in order to dry your food. You have the first combustion, and you have the combustion air circuit, and then you have another circuit of clean air, which is indirectly heated by the first circuit, and then this clean air is drying your product. And of course, it's very sustainable. You have also the alternative of solar drying, and on the right picture, you see some solar drying tents, and you use the solar energy in order to dry your product. Of course, these tents must be heavily ventilated also, but they prevent, of course, also rain falling into your product and spoiling your product. And the last example is olive oil, mainly in North Africa, on the Mediterranean area around the Mediterranean Sea, but also in Southern Europe, as in Spain, Greece, and Italy. And you have the whole process over there, from harvesting until the finished product. And here we see the harvesting machines. It's like in the wine trees harvesting. They are just going over the smaller olive trees, bushes, and harvesting there directly. And they produce, of course, exhaust fumes. But also these tree shakers, and you see it in the middle of the middle picture. You have pneumatic tubings, and they can, of course, go defect, and then spoil the olives which have fallen down. In the right picture, you see this kind of tractors which are shaking very heavily the trees in order that the olives fall down. But also this trimming of the trees during the harvest with motor saws, which produce exhaust gases, can be a relevant source of MOAH and MOAH. What we have discussed are the jute bags and the MOAH or the mineral oil which are used for treating these jute bags in order that they can be multiply used and that they are not going defect too easily and too quickly. But also other options. If you are in an olive oil plant, you have a lot of gearboxes, bearings, and hoppers. You have gearboxes and motors over the process. You have a lot of sealings which could be defect. However, in this case, what we investigated, and with this partner we talked to in the olive case here, it was really the jute bags which were the main factor of migration of mineral oil, MOAH and MOAH, into our product. I'm very happy, really. I'm very happy that the ESA, the European Cocoa Association, in cooperation with the European Coffee Federation, ECF, they have published a joint industry specification for jute bags, and they have published also on their web page, which you see here. You see the QR code. you get a lot of information also what can be done in order to have good jute bags which do not or which limit the recontamination of MOAH and MOAH into your products, namely rice, cacao, spices, and coffee, but also others. And these vegetable oil treating of jute bags, this is a small step only on this way. And they have found out that even those vegetable oil treated jute bags have a heavy contamination of MOAH and MOAH into your product. And there must be also other steps must be done in order to limit the contamination of MOAH and MOAH into your products. And these ESA, and they have already spoken to a lot of stakeholders in the jute business in Cote d'Ivoire, in India, in Ghana, in Bangladesh, and others. So this information needs really to be spread in the whole world. And please, if you have this case, please try to contact via ESA what can be done. Okay, I have to skip. So if you have looked very deeply in your process and you have at your own process or in the process of your supplier, and you have seen a possible way where MOAH and MOAH could enter in your products. So what can you do in order to see whether this point is really relevant? Usually this is done by making or by committing step testings and of course then analytics. What do I mean with this? So you are going through your production or through your process or the process of your supplier, and then you are taking samples at every step of the process. And this is not too much. So limit it really on let's say, maximum 5 or 6 steps. If needed, you can later on go deeper in detail. But you take samples of all the relevant steps, and then you analyze these samples from the steps. And from one point on, and here in this example, you have seen the samples taken after step 1 and 2, you do see nothing in the analytics. So it's everything is under the level of detection. In this case, it's 0.6 milligram per kilogram. It's depending also on the laboratory. But relevant, of course, relevant are the level of detection which are named or which are fixed in the legislation of the EU. So after step 1 and step 2, you do see nothing, and then but after step 3, and then you see that there has been a contamination of MOAH and MOAH. So what happened between after 2 and 3? You go then deeper into the detail, and then you can identify which is the relevant step and which is the relevant point where MOAH and MOAH is migrating into your product. I hope that this is a little bit clear. So finally, I would like to talk about labs and taking samples. There have been a lot of discussions of labs where the labs are suitable to do this analytics, and we have been discussing about the fact that for some materials like spices or essential oils, there are a lot of naturally occurring substances that are which are interfering with the method, and so please, this is really please do use labs which have a lot of experience with MOAH and MOAH. Of course, these labs need to analyze MOAH and MOAH already since quite a lot of years, and this of course takes time and experience, and this is also somewhat costly. This is true. If these labs are not available in your exporting country, on your country from where you export into the EU, then of course you could also subcontract other experienced lab. You can do it if you want to know which labs are experienced. There is a list by the EURL PC, and this is the abbreviation for European Union Reference Laboratory for Processing Contaminants. And if you send an email to them under the email address with this reference and the subject field, you will get a list of which are the approved labs which have a lot of experience in this field. A lot of them are in Europe still, this is true, but there are also a rising number of labs in Asia and also in Africa and South Africa and the other parts of the world. There are labs from the big labs, from the multinational labs. They have offices in the capitals in your continents. And so they will then organize the transport of the samples from your country into the relevant labs in Europe. And if this is not an alternative for you or an option for you, you can also ask your customers in the EU and ask them friendly whether they could support you in analyzing the samples for you, and you make a deal with them however you do it. So there are some options, but what I want to tell you is don't use a lab which you don't know whether they are experienced, because then you get of course you get a result, but it happens very often that then you are mistrapped, or you find positive, false positive or false negative results, and this really doesn't help you at all, because then you go, when you investigate later on, you go totally in the wrong direction. So the recommended method for food, and there's only, let's say, one recommended method, and for non-chemical food chemists, this is a little bit complicated, but this is an LC-GC-FID method. Here you have the link to the GRC guidance, and you have also see the worldwide norm. It's an ISO norm 20122. So this is a method which has been used for quite some lot of years and which is suitable for your products. And this method takes care that also we have talked about the biogenic substances which are naturally present in plants that might disturb the analytics. These labs, with using this method, they know how to avoid false negative or false positive results because of that. And one of the magic words here in this context is epoxidation. So these biogenic substances, which you see here as peaks, they are rubbed off from the analytical chromatogram, and then only the true MOAH, namely the MOAH components, are measured. But you don't have to take care about this. So if you use a lab which has experience, optimally from the list, yeah, then of course they know what they do, and the results are reliable. Last but not least, to finish, you have identified the risk in your process. You have taken samples and you have sent the samples to a lab. But what about the contamination of your sampling containers? We have seen in a lot of cases that there could be a contamination via your sampling containers. And as you can see on the right pictures, you have these aluminum lids, and inside these aluminum lids there is a rubber sealing in order to make the jar tight. And these rubber seals, they can contain substances which are analyzed as MOAH and MOAH. Some plastic lids, some plastic jars, plastic sacks, or some lacquers in metal boxes, yeah, we see on the left side we see this glass, it's coconut glass, and you have the lids with the rubber sealing around. These are all possibilities how MOAH can enter in your product, and which has no MOAH and MOAH at all, and afterwards the result is there, and there is a false positive result. And the EU also has taken care of that, and they propose in regulation 333/2007. It's also here, and the link is also here. That all precautions have to be taken, that there is no contamination of the product via the container of the sampling. And some of the main tips I can give you, and which are also given in this annex of the regulation, or in this annex will then be amended in a short time. So plastic containers, yes, you can use them, of course. However, they are a possibly source of contamination. So if you use them and you cannot avoid them, then please check them whether there is MOAH or MOAH entering via the container into your product. How can you do it? You can analyze your sample in these kind of plastic containers, and you can use it and you can analyze it in a glass container alternatively. And if you see that there is no difference, then possibly your plastic container is okay. If you have lids, please prefer glass stoppers. I know that glass lids are not very adequate for a lot of options, but you can make a PTFE. So this is Teflon. It's also named Teflon to layer it, or you cover the lid or the surface of your glass of your container. You cover it with aluminum foil, and then you put the lid on it. And you should avoid rubber rings to use to close containers, and you should avoid lids which have these rubber sealings inside. If you have them, then also work with the aluminum foil. And if you have pre-packed food in, let's say, in a plastic sack or whatever, can happen that this pre-packed food can contaminate another sample with another plastic sack. So from one sack to another sack. So use aluminum foil and wrap it around in order to cross-contaminate other samples which are around. And of course, avoid paper or plastic labels. Paper and cardboard. We have seen that recycled paper and cardboard could have a very hard impact. There's a very heavy way of migration of MOAH and MOAH into food. And as I said already, containers and also optimally the aluminum foil should be checked for mineral oil, hydrocarbon contamination prior to using it. So check it once. Of course, this is additional effort, but check it once before you use the container. And if you use a container, let's say for pulses, and it works, it must not be the case if you use the same container with a vegetable oil, because it's always the combination of container and sample, category of sample, which makes it whether it works or not, whether there is a contamination or not. So try it in order to analyze 2 or 3 times on different packagings, and then you see whether you have a contamination via your packaging. And then you are fine, and then you can use it if there is no contamination. Thank you very much. It's nearly, I've started a little bit later, but I am at the end of my presentation.
Thank you very much, Michael. And if that's okay,